In recent astronomical observations, a phenomenon of staggering magnitude has emerged, capturing the focused attention of the scientific community and stirring a wave of intrigue across the globe. A massive dark expanse, akin to a colossal celestial blemish, has been detected upon the solar canvas our very own sun. This phenomenon, known as a coronal, has presented itself with unprecedented scale, dwarfing our Earth 60-fold in its shadow. This coronal hole, a region on the sun's surface marked by reduced temperature and lower density plasma, casts an ominous silhouette against the otherwise blazing backdrop of our star. It is a window into the solar abyss from which solar winds escape at velocities, but are both astonishing and potentially disruptive. Originating near the sun's equator in early December 2023, this vast coronal hole expanded at an astonishing rate, reaching its peak extent of 800.0 kilometers in a mere 24 hours. This expansion is significant enough to comfortably encompass 60 Earths side by side. The appearance of such a grandiose coronal hole has not been without consequence. The sun, a furnace of nuclear reactions and magnetic activity, has expelled streams of energetic particles from this opening, directing a barrage of solar radiation towards Earth. The phenomenon of coronals is not new to astronomers. These regions have been observed with regularity, typically appearing with more frequency during the sun's quieter phases and often located at its poles. However, the scale and timing of this particular coronal hole defy the patterns previously recognized by solar scientists. The concern among the scientific community is palpable. The potential for solar storms, induced by the outpouring of charged particles from the coronal hole, looms over Earth. Such storms carry the power to disturb the magnetosphere, affect satellite operations, and, in more severe instances, disrupt electrical grids on a planet's surface. Yet, despite the potential for disturbance, these solar winds also hold the promise of natural spectacles in the form of auroras, those mesmerizing light shows at the poles, which may display enhanced vibrancy and reach due to the increased solar activity. Understanding the significance of this coronal hole requires a journey into the nature of our sun. The solar surface, a rolling expanse of plasma and magnetic fields, is punctuated by regions where the sun's magnetic field opens out into space. These are the coronal holes, areas where the high-speed solar wind is funneled out into the solar system, typically darker and cooler than their surroundings. These holes were visible to us, thanks to modern satellite imagery and sophisticated detection methods. The recent observations by space weather monitoring systems have shown that this particular coronal hole has directed a stream of particles squarely toward Earth. The implications of such an event are wide-ranging. As the charged particles collide with Earth's magnetic field, it could spark geomagnetic storms of varying intensities, while the direct hit from such a solar wind stream can lead to disruptions. It also bestows Earth with the possibility of breathtaking auroral displays. The likelihood of such an event causing profound disturbances to Earth's technological systems has been subject of intense scrutiny. Space weather forecasters have been closely monitoring the situation, providing updates and predictions on the potential impacts, where the event has warranted caution. The scientific community remains vigilant yet measured in their response, acknowledging the inherent uncertainty in predicting space weather events. The event serves as a reminder of our planet's vulnerability to the whims of solar activity. As humanity's reliance on technology grows, so too does the importance of understanding predicting solar phenomena. The coronal hole, a stark reminder of the dynamic and sometimes unpredictable nature of the sun, underscores the necessity for continued research and preparedness in the realm of space weather. As the Earth continues its orbit, eyes remain fixed upon us, watching as the coronal hole begins its slow rotation away from direct alignment with our planet. The solar winds have eased, and the threat of a geomagnetic storm has subsided for now. However, the occurrence has sparked a renewed interest in solar dynamics, driving scientists to delve deeper into the mechanisms that govern our star's behavior. In the wake of this event, scientists have gathered a wealth of data, contributing to the collective understanding of solar processes. Each observation, each measurement, adds to the intricate tapestry of knowledge that forms the basis of solar physics. While the coronal hole may have faded from direct view, the lessons gleaned from its appearance will resonate far beyond this singular event. The occurrence of such a large coronal hole has also ignited discussions on the need for robust space weather forecasting systems. As we advance into an era where our infrastructure, both on Earth and in orbit, is increasingly susceptible to solar activity, the demand for accurate predictions and effective mitigation strategies becomes more pressing. The scientific community is called upon to innovate and develop tools that will safeguard our technology-dependent society from the caprices of the sun. In conclusion, the Coronal of 2023 has served as a significant point of study, prompting us to reassess our understanding of solar phenomena and their potential. While the immediate threat may have waned, the episode has propelled solar science into the public consciousness, highlighting the importance of our star in the tapestry of cosmic events that directly affect life on our planet. As we ponder the implications of this solar event, it's essential to recognize the strides we've made in solar observation and space weather prediction. The past decades have seen a considerable advancement in our ability to monitor the sun's activity. Satellites equipped with cutting-edge instruments, such as the Solar Dynamics Observatory (SDA) and the Parker Solar Probe, have provided unprecedented insight into the sun's atmosphere, known as the corona, and its effects on the space environment surrounding Earth. The data from these observatories contribute to a more nuanced understanding of how coronal holes, solar flares, and coronal mass ejections evolve and interact with the vast bubble-like region of space dominated by the solar wind and magnetic fields. Such knowledge is vital for preparing for future solar events that could have even more pronounced effects on our planet. Looking ahead, the scientific community is poised to continue its vigilant watch over the sun. The upcoming Solar Orbiter mission, collaboration between the European Space Agency (ESA) and NASA, is set to launch in the near future, providing an even closer look at the sun's polar regions, which are challenging to observe from Earth. This mission promises to shed light on many unanswered questions about the sun's behavior, including the formation and evolution of coronal holes and their influence on space weather. Moreover, this incident has emphasized the importance of international cooperation in the field of space weather. The potential for solar activity to affect regions across the globe. Sharing information and resources is crucial for a timely and effective response. The role of organizations like the International Space Environment Service and the World Meteorological Organization is more critical than ever, as they coordinate the dissemination of space weather alerts and forecasts. The increasing complexity of our technological infrastructure, from power grids to global communication systems, underscores the urgency of enhancing our predictive capabilities. This endeavor, machine learning and artificial intelligence, are emerging as powerful tools for analyzing vast amounts of solar data being collected, identifying patterns, and predicting solar storms before they reach Earth. The fascination with our sun goes beyond the realms of science and into the cultural fabric of our society. Solar phenomena have inspired art, literature, and mythology throughout human history, and today they remind us of our place in the larger cosmic narrative. The recent solar event, while cause for scientific concern, also offers an opportunity for collective awe and a deeper appreciation for the forces that govern our universe. As we continue to explore the mysteries of our sun, we remain humbly aware of our position in the cosmos. The coronal hole of 2023 has not only been a subject of scientific study, but also a catalyst for reflection on our vulnerability and resilience in the face of cosmic forces. It is a stark reminder of the need for ongoing vigilance and the pursuit of knowledge in the age of a technologically interconnected Earth. In closing, the coronal hole event stands as a testament to the dynamic and changing nature of our solar system. It invites us to look up and wonder, to question and seek answers, and prepare and protect our world from the potential perils of space weather. As we bid farewell to the coronal hole, it captivated our attention. We carry forward the lessons learned and the sense of wonder it has instilled in us all. Certainly. Let's continue from where we left off, expanding on the solar phenomena and their implications for our understanding of space weather and celestial mechanics. The discovery of an immense coronal hole on the sun's surface has served as a profound reminder of our star's unpredictable nature. As vast, dark expanse, sprawling more than 60 times the size of Earth, emerged suddenly, challenging our perceptions and knowledge of solar activity. Its appearance near the solar equator, rather than at the poles as commonly observed, suggests an anomaly that defies current scientific understanding. These coronal holes are regions of the sun's atmosphere where the magnetic field opens up and allows solar wind to escape into space. The phenomenon is not new, however. The scale and timing of this particular hole have raised eyebrows in the scientific community. This disruption to the expected solar cycle patterns may indicate that our predictive models need refinement. The potential consequences of such a solar event cannot be overstated. Coronal holes are the source of high-speed solar wind streams that can interact with Earth's magnetosphere, potentially sparking geomagnetic storms. These storms can disrupt satellite operations, affect radio communications, and even pose risks to astronauts in space. On Earth, they can lead to the awe-inspiring auroras near the poles, but they can also threaten electrical grids and infrastructure. The occurrence of this colossal coronal hole has brought to the forefront a critical need for advanced monitoring systems. The urgency is compounded by our increasing reliance on technology susceptible to solar, whether everything from GPS navigation to power distribution hinges on the stability of a space environment. Hence, there's a push for more robust space weather forecasting capabilities, akin to terrestrial weather prediction services, to provide warnings and mitigate potential impacts, as we enhance our observation networks. We also delve into research that could reveal the fundamental processes driving these solar phenomena, the dynamics of the sun's magnetic fields, the mechanisms of coronal heating, and origins of the solar wind are subjects of intense study. Each discovery not only enriches our scientific knowledge, but also equips us with the insights necessary to better safeguard our technological society. In addition to scientific advancements, the coronal hole has sparked a renewed interest in the educational and outreach aspects of space science. It underscores the importance of making space weather a part of public awareness, ensuring that the information reaches those who need it most, from policymakers and industry leaders to educators and students. This moment in our astronomical journey also highlights the beauty and power of nature that extends far beyond our earthly confines. The stunning visual of a coronal hole, captured by sophisticated instruments aboard solar observation satellites, not only informs our understanding, but also inspires a sense of wonder and curiosity about the universe we inhabit. Furthermore, these celestial events foster international collaboration. Space weather knows no national boundaries, and its effects are global. Thus, the shared experience of monitoring and responding to solar activity brings together scientists, researchers, and institutions worldwide. This collaborative spirit is a beacon of how humanity can unite in the face of universal challenges. In essence, the vast coronal hole of 2023 has become a symbol of both our vulnerability to and our capacity for understanding cosmic phenomena. It is a powerful reminder that, as we gaze upon the night sky, we are not merely observers but participants in an ever-evolving cosmic story. As we venture further into the depths of space, we carry with us a profound respect for the forces that shape our universe and a commitment to prepare for the celestial events that lie ahead. With these thoughts in mind, we anticipate the next chapters in our solar narrative with eagerness and preparedness, ready to learn and adapt to whatever the sun may unveil. The coronal hole has been a profound teacher, and its lessons will resonate as we continue to explore and cherish the cosmic dance of our star and its planetary companions.